Okay, welcome back. Now we're going to do a couple of examples. One is an even function and one is an odd function. So you can tell that this is an odd function. Well, one, you should know that sine x is an odd function. Okay, so this is an odd function. And then this is an even function. You should be able to tell that this is an even function because all of the exponents on the terms are even, right? So this is x to the 0, x to the 8th, so it's an even function. That's one of the shortcut ways. Sine, we should know that that's an even function just from previous classes and the behavior of knowing the behavior of the graph, what the graph looks like. So anyway, so what we're going to do is now, since this is an even function, I'm going to use what we learned in the last video about what to do with these, about integrals of even functions. So I know that this is going to be equal to the integral from 0 to 2 of 3x to the 8th minus 2. Okay, why? Because it's an even function, it's symmetric with respect to the y-axis, and so therefore I can split the range, the range of the interval of the integration in half. And so now this is going to equal 3/9 x to the 9th minus 2x evaluated from 0 to 2. And of course this is going to be easier to evaluate because I've got 0 there. And so now this is going to equal 1/3 times 2 to the 9th minus 2 times 2. And of course, at 0, this is just going to be 0, so I'm just going to subtract off 0, which isn't going to change anything, so it's gone. And so now, what do I get? Here, 2 to the 9th. 2 to the 9th is going to be 512, so I get 512 over 3 minus 4, which is the same as 12 over 3, which gives me 500 over 3. Now, the thing is that this is not equal to this unless I put a 2 out here. This is the same as twice this, which is equal to 2 times this, which is equal to 2 times this, which is equal to, 2 times this, which is equal to 2 times this, which is equal to 1,000 over 3. And so, that's how you do it. Now don't forget the 2, don't forget to multiply this by 2. So again, if it's an even function, this is equal to twice this. And then you'll get the same answer. So if you want to verify, go ahead and do it. Run the integration, evaluate the integration from -2 to 2, and you should get 1,000 over 3. Okay, now, this is an odd function, so we know that this integral, the evaluation of this integral will be 0. Okay, but let's prove it. Let's verify that. So, again, this is going to be an integral from -pi to pi. I'm going to pull the 5 out and leave the negative. So this is going to be negative sine x dx. And so, again, the antiderivative of negative sine x is cosine x. So this is going to become 5 times cosine x evaluated from -pi to pi. And now, let's evaluate. So this is going to be 5 times cosine of, that's a negative, okay. The cosine of pi minus the cosine of -pi. Okay. Now the cosine of pi, what's the cosine of pi? Cosine of pi is -1. or excuse me, no, positive 1. I was going the wrong way. The cosine of pi, I think I said, wait. The cosine of pi is 1. Oh no, negative 1. I was right the first time. The cosine of pi is negative 1. Okay? Minus the cosine of negative pi is also negative 1. Which means this becomes a plus 1, right? Which gives me 5 times 0, which equals 0, which is exactly what I said it was going to be. Have a good day.